My name is Keshav Campbell. Today we are going to do a deep dive on a threat model that is automatically generated by the Avocado security platform's Avocado Reveal. In front of you on the browser, you are seeing multiple circles. This particular application architecture model is an HTML format of the application model. Each circle represents individual application module or architectural module, sometimes submodule, discovered by the Avocado Reveal. Each circle has its own color coding as well. Some of them are red colored, which represents the architectural modules, which has vulnerabilities or attacks or exploits or threats. Then some of them are plain yellowish, which has certain element of unknown attributes. And then you may see multiple green colored or clustered ones, which are representations of large number of microservices threat modeled in this particular architecture model. You may see multiple client processes ingressing into multiple application modules, and you may see multiple egress arrows going out to internal or external servers based on the application's activity. Now, number one, this particular picture is an architectural picture of an application in runtime. The Avocado Reveal discovered every module here that is part of the application called Acme CRM multi-node application ecosystem. Every module was discovered independently, analyzed independently, and threat modeled independently, and put into the total picture automatically. So this particular architecture model that you're seeing is actually on demand available through the Avocado security orchestration. Now let's go deep into the model. The model has two dotted lines. One is outside, which represents Avocado orchestrator boundaries, and the one inside says two node CRM application, which basically a boundary for threat modeling the Acme CRM two node application. As part of the threat modeling, multiple processes discovered includes Zookeeper and Kafka-based messaging buses. You would see multiple instances of those here. Then multiple Tomcat servers discovered. Then Elasticsearch elements discovered. You have two node Elasticsearch here. And then there is a SQL server discovered. And then there are multiple microservices in the form of a cluster. We would be going deep into that. And then client process and backend process. So first, let us go deep into the MySQL server. So by clicking on this MySQL server circle, you can see the attributes of the MySQL database itself. So that's the application name out there. Some of the alternative names used for that same MySQL server. The SQL server is running on these IP addresses. The host names are also available here. Now the application path used for that MySQL server is this, and most important is the MySQL server is using two ports for different activities. They are open dynamically. They are mentioned here, the TCP port 3306 and 33060. Now total number of vulnerabilities by synthesis and analysis discovered here are 87. You can then look into those vulnerabilities by clicking on this particular entry called application version information. So all the vulnerabilities that are discovered here, they are based on the MySQL Server version 8.0.27. So by clicking on this particular MySQL Server circle, you can see all the vulnerabilities associated to that particular MySQL Server. Now, there are additional links to the information leading to the vulnerabilities associated here. So every CVE ID has its internal link as well, which you can click and see more details on that particular vulnerability. But most important thing here is MySQL is part of the architecture of this CRM application, and MySQL constitutes quite a large number of vulnerabilities here, total 87. And the MySQL version used here in this architecture is from Oracle version 8.0.27. Now, you can see more things with this particular architecture. By double clicking, you can see all the elements of the architecture which are talking to MySQL server. So by double clicking, you can see these two ingress lines coming in. Now, all of these ingress connections, these are called architectural dependencies. Every module depend on the other module in the form of APIs, in the form of RPC, IPC, or any other mechanism, or even the SQL queries. In this particular case, because MySQL database is a SQL database, all the dependencies will be in the form of SQL queries. So you can see that MySQL has communications coming in from microservices as well as some clients which are internal again. They are also talking to MySQL database. Now, let us look at a little bit more into Kafka-based services. So Kafka, as you know, is a messaging bus. It's an, again, open source mechanism provided by Apache services. Kafka and Zookeeper was discovered in the same application architecture dynamically, and it has a set of vulnerabilities. Again, you can see the attributes of Kafka here, and then the set of vulnerabilities associated to that particular Kafka. Now, in this case, Kafka version 17.0.5 is used in this architecture, and the vulnerabilities associated are listed here. Again, by double clicking on this particular Kafka block, you can see all the interdependencies of the Kafka and other modules with each other. So Kafka obviously talks to Zookeeper, and Kafka is also used by all the microservices in this case, and then some external processes in that equation. So you can actually study all the dependencies here by hovering over this particular line. You can see the attributes of this particular dependency, that Kafka is talking to Zookeeper for certain reasons, and the Zookeeper has port number 2181 opened for communication purposes on that, and then you can actually deep dive into that. Now, you have ability to reset or zoom in and zoom out the model. You can also look at, most importantly, the microservices now. So let us look at the microservices. In this particular case, these microservices, if you click on the microservices block, you would see all the microservices popped up here. Then you can look into each microservice independently, and you can study each microservice independent of the others. So this particular microservice I'm looking at, it has multiple internal services. It has internal accesses to databases. It has internal accesses to the NoSQL databases as well. And then there is a client connection that is basically logging into that particular information. So the ability to study microservices is significant here. The microservices may range from just one microservice to thousands of microservices, and you would still be able to threat model each of them. And again, the threat modeling includes discovery of architectures, plotting the architecture as much precisely as you can, and then every individual module is studied for various threats, various vulnerabilities, various attacks in runtime of those applications. Moreover, these applications can run in pre-production, QA environment, unit testing, DevOps environments. These particular threat models, advantage number one is it gives you the most precise picture of the application of your dynamic services, including the comprehensive architecture of your application. Number two, every module and submodule is threat modeled independently, parallelly, and then the holistic picture is stitched together to give you the most precise understanding of the, the application architecture, scalability of your applications, interdependencies of your application modules, their attributes, the data transactions performed, and the vulnerabilities associated to your application ecosystem. Thank you very much for listening into the demo.